Welcome to Math with Mrs. Bibb. Today we will be discussing properties of exponents. First we want to define a monomial. A monomial is a number a variable or a product of a number and one or more variables. It has only one term. Now what that means, there are no addition or subtraction signs. It can be negative, so don't mistake a negative sign for a subtraction sign. There are no addition or subtraction signs. One single term. And a variable cannot be in the denominator for it to be a monomial. Okay, I'm going to make a list of things, and we're going to see if they are monomials. And they may not all be monomials. We will circle the monomials. Here's our list. 5x negative 3x squared y cubed negative 4 over 2x negative 1/3 x 18x squared y cubed z squared. Now we're going to circle the monomials. Let's see if it fits the description. I'm going to add one more. So I'm going to add the number 10 to the list, and that's it. So hopefully you can squeeze 10 over there. Okay, so 10 is a number. That's a monomial. A number and a variable, 5x, that's a monomial. A product of a number and one or more variables, so this is a monomial. 18x squared, y cubed, z squared, that is a monomial. Negative 1/3 times x, that is a monomial. This is the only one that is not a monomial because x is in the denominator. Okay, let's look at some exponent rules. These rules are so very important, so please make sure you keep this sheet. I know throughout this school year, as I helped my juniors with their Khan Academy work, exponent rules were one of the number one things that the students completely forgot. They just let those rules leave their mind. The first thing I want to point out is the word product means to multiply. The word power means exponent. So exponent with an exponent. Exponent when you're multiplying. This means to divide with exponents. So let's go through the rules. The product of powers. That means if you are going to multiply two bases, and the first base has an exponent of the letter C, and the second base has an exponent of the letter D, then your answer or your product is the base with the exponents added. power of a power. That means you have one base, maybe raised to a power, could be one there, and then you have another power that it's being raised to. So this is called power of a power. When you have power of a power, you multiply your exponents. Power of a product. When you have power of a product, you have two bases, two different bases or more, raised to a power. And when you have that, you raise the base, each base to that power, and then you multiply. So A would be raised to the m power, and B would be raised to the m power. So that's called power of a product. Now, quotient of a power, that means when we are dividing, if you have the same base raised to two different powers, or the same power, it doesn't matter, then you would subtract your exponents. Okay, the next rule, power of a quotient. For my power of a quotient, I am going to realize that I have a division problem. I have two bases raised to a power, and I'm going to raise each base to that power that's on the outside, and then I will simplify. Okay, next, power of a quotient with variables. That just means that you're going to have more than one base, like A, B, C, D, and they're going to be raised to a power, and you just raise each of those to a power, to that power, and then you simplify. And then remember, if you have exponents here, you multiply those exponents when you do that power of a quotient, because it's still power of a power also. So if you have a power here, you multiply this power times this. So that would be power of a power also. Next, we're going to zero exponents. The next rule, zero exponents. If you have any non-zero number, so that's going to be A, and that non-zero number is raised to the zero power, then the answer will always be 1. Students will always say, well, the answer is going to be 0. No, the answer will always be 1 if you raise anything to the zero power. I want to also point out, it wasn't part of the lessons in the textbook, but if you have a product of multiple things raised to the zero power, that is still 1. Even if I had a quotient, I'm not going to write it down, but I'm going to point it out up here. So even if I had this raised to the zero power, this would still be 1. Anything raised to the zero power is 1. Now on to negative exponents. When I look at negative exponents, I know that if I have a base raised to a negative exponent, you cannot have a simplified answer if you have a negative exponent. So what you do is you move, I'm going to highlight, you move that base to the opposite place it is. I'm going to do 2 examples so you can see that. So I move A to the denominator, and I make the exponent positive, and 1 has to be in the numerator. So vice versa of that, if you start with 1 over A to the negative n, I have to make that a positive exponent. So I move this base to the opposite place it is. I put it in the numerator. I make that A to the positive n. And you do not have to put a 1 underneath that. this can be the answer. 1 over a to the negative n is a to the positive n power. Now, if you have a fraction raised to a negative exponent, and I really like this, so try to remember this rule. There's so many different rules and so many different ways you can apply them, because our first instinct is to raise each of these to that power. But if you have a negative exponent on the outside, then make that a positive exponent and switch your numerator and denominator. So a over b, or a divided by b, raised to the negative n power is b divided by a raised to the positive n power. So don't forget that really good rule to have. Okay, we will do some examples. For example 1, we're going to explore some product of powers rules. If you'll look back at your product of powers, it tells you that when you have the same base, you add your exponents. Now, I'm going to go through this first example a little bit differently. You do not have to do this every time. So this is just an extra way for you to be thinking. When you look at this, 3 times n to the 4th times 4 times n to the 7th, we're multiplying a monomial and a monomial. So we can shuffle stuff around, use the commutative property of multiplication, and we can rewrite this to look like an easier way to multiply. We can say, okay, I'm going to multiply 3 times 4, and I'm going to multiply n to the 4th and n to the 7th. This only works because I'm multiplying 2 monomials. And then we all know that 3 times 4 is 12. And n to the 4th times n to the 7th. I have the same base, so I add my exponents. On this one, I'm going to go ahead and just write 4 plus 7, but you do not have to write that. That would be n to the 11th power. 12 times n to the 11th is the answer to that example. Now let's look at example B, here in example 1. I'm going to multiply 7xy squared times 2x to the 4th, y to the 3rd. I think I will rewrite that again because it may help some students for me to show you that way to multiply by rewriting. So you're going to multiply your coefficients. You're going to multiply your x's. And you're going to multiply your y's. And again, this only works because we are multiplying a monomial and a monomial. So 7 times 2 is 14. X to the 1st times x to the 4th is x to the 5th power because you add. Y to the 7th times y to the 3rd is y to the 10th power because you add the exponents. So add exponents. That's what that rule is here. When you are multiplying the same base, add the exponents. Now we're going to talk about the power of a power. If you have a base raised to a power already, and then you raise it to another power, this is n to the 5th raised to the 3rd power, then you multiply your exponents. 5 times 3, n to the 15th. For the second one, and that's my answer, n to the 15th. For the second one, if you have a base raised to a power, and then that's raised to a power, then you multiply your exponents. X equals 4 times 2, which is x to the 8th. So when you have power of a power, multiply exponents. The next example, power of a product. So I have 3x to the 5th, y to the 2nd, raised to the 5th power. So my power of a product tells me that I am going to do 3 raised to the 5th power, x to the fifth raised to the fifth power, and y to the second raised to the fifth power. And I can only do this again because I have a monomial that I'm raising to the fifth power. 3 to the fifth power. Remember, that's 3 times 3 times 3 times 3 times 3. So 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. And I wrote 234. Did you all see that? 243. X to the fifth raised to the fifth power is x to the 25th. 5 times 5 is 25. Y to the second raised to the fifth power is y to the 10th, because 2 times 5 is 10. So multiply exponents here. That way you'll have that in case you need to look back to see how we got an answer. For my second one, negative 5a b to the fourth raised to the second power. So that means I'm taking negative 5 to the second power. I'm taking a to the second power and b to the fourth to the second power. So I have 25 a squared because 1 times 2 is 2. B to the 8th because 4 times 2 is 8. Multiply your exponents. For the next example, I am going to have the quotient of powers. So I'm going to have b to the fifth power times c to the seventh power divided by b to the second power times c. Now, I do this a little bit differently than a lot of teachers do because I try to make sure that we keep our exponents positive. So the first question I tell students to ask themselves is, where is your exponent the largest? Where is your b's exponent the largest? Well, that's in the numerator. So my b is going to be in the numerator. And then I subtract my exponents from there, 5 minus 2. And then where is my c's exponent the largest? That's the numerator. So I really don't need this bar here. I'll get rid of it. It will stay in the numerator, and I'll subtract 7 minus 1. So my answer will be b to the third power times c to the sixth power. So you could have m squared n cubed p divided by m to the fifth n p. So let's see what happens. Where is my exponent for my m the largest? In the denominator. So it's going to stay there. I'm going to subtract from there, m to the 5 minus 2. Where is my n's, where is my n exponent the largest? And that's in the numerator, so it's going to stay there. N to the 3 minus 1. Where is my p's exponent the largest? Well, it's the same. And when it's the same, 1 minus 1 is 0. It cancels out. So the answer I will get is n to the second power in my numerator and m to the third power in my denominator. That is my answer for example 4. For example 5, the next one that I'm going to do is the power of a quotient. So I have, for my first example, I have 5a squared over 6 raised to the third power. So I am going to raise each of these to the third power. So don't forget, you're doing your power of a quotient, and it's the power of a power also. Now I'm going to actually raise all those to the third power. 5 to the third power is 5 times 5 times 5, which is 125. A squared to the third power, I'm going to do a to the 2 times 3. So that's a to the sixth power. 6 to the third power is 6 times 6 times 6, which is 36 times 6, which is 36, carry the 3, 18, 216. And 125 and 216 cannot reduce, so this is my answer. For letter B, I have 2 m to the second n to the third divided by 3 k to the fourth. And all of that is raised to the fourth power. So you raise each of those to the fourth power. 2 to the fourth power, m squared to the fourth power, times n cubed to the fourth power, divided by 3 to the fourth power, times k to the fourth power. So I'm going to have 2 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So 32 m to the 8th power, n to the 12th power, divided by 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, k to the 16th power. That is the answer to my example 5. For example 6, I'm going to do power of a quotient with variables. And I only have one of these. So I'm going to do x to the fourth power, y, divided by x, y, z. And that is raised to the second power. And I'm going to tell you honestly what I would do first. I would see if I could simplify within here. And that is not what the textbook says to do. But I always start, just like order of operations says, I start in the parentheses. Can I use any of those rules that we've used prior to example 6? And yes, I can. I'm dividing with the same base, so I can subtract these exponents. My x will stay in the numerator because it is bigger in the numerator, and I'll do 4 minus 1 and get 3, and I'll do that in just a moment. And then my y's, these exponents are the same. So 1 minus 1 is 0. That's going to go away, and only z is going to be left in the denominator. That is my personal advice. Do order of operations, do what's inside first if you can. If there's nothing to do in there, then you have no choice to do that power or quotient of a power, or however they worded it with variables. So I'm going to simplify, have x in the numerator, 4 minus 1 is 3. My y's will cancel out, and have z in the denominator and raise that to the second power. And then I'm going to have x to the third raised to the second power, and z raised to the second power. So my answer is x to the sixth divided by z to the second power. Moving on to the next example. For example 7, we'll look at some 0 powers, 0 exponents if you will. So my letter A, I have negative 8 m squared n p to the 8th divided by 9 k squared m n to the 4th, and all of that is raised to the 0 power. And when I raise all of that to the 0 power, I get 1. Now normally, like I said, I start inside and simplify, and my n's would simplify and my m's would simplify, but Since 0 is on the outside, I don't even worry about simplifying on the inside. Anything to the 0 power is 1. Now look at this next one. Can you see the difference between letter A and letter B? The next one says a to the 4th times b to the 0 divided by a to the 2nd. And hopefully you can tell that there's a difference in that. That's a to the 4th times 1 divided by a to the 2nd. And anything times 1 is going to be itself. So I have a to the 4th divided by a to the 2nd. Now I have a quotient, and my exponent for my a is bigger up top. So my answer is going to be a, and then I subtract 4 and 2. So my answer is going to be a to the 2nd power. Next, we are going to work with negative exponents. So we're going to look at what we could see with a negative exponent. My first example looks like this. M squared n to the negative 3. So to simplify that, then I keep m squared in the numerator. I put n in the denominator and make it a positive 3. That's my answer. For my second one, I have x, y divided by x to the negative 2, y to the 3rd, all raised to the negative 3 power. Okay. I'm going to simplify inside first. So I'm going to be consistent with what I said. I'm going to simplify in here. Where is my x's exponent the biggest? In the numerator. So my x is going to remain in the numerator. We'll keep that negative 3 on the outside. X will remain in the numerator. 1 minus negative 2 is 3, x to the 3rd. Where is my y's exponent the biggest? In the denominator, so I'm going to put y here. And 3 minus 1 is 2. Y, 3 minus 1 is 2. So I've simplified inside. Now I'm going to take care of this negative exponent. I'm not going to do the power of a power, I'm going to take care of this negative exponent. When you have a fraction raised to a negative exponent, you flip over that fraction. So that would become y to the 2nd divided by x to the 3rd, all of that raised to the 3rd power. Now I do my power of a quotient. Y to the 2nd raised to the 3rd power is y to the 6th, because 2 times 3 is 6. X to the 3rd raised to the 3rd power is x to the 9th, because 3 times 3 is 9. For my next example, I am going to simplify with negative exponents. So letter A, I have a to the 3rd, b to the negative 4, and c to the negative 2nd. I can't simplify anything, but I need to move this base to the denominator, make this a positive 4, and move this base to the numerator and make this a positive 2. And that's all you do. There's really no work you can show. So a to the 3rd remains, c to the 2nd power is in the numerator with a to the 3rd, and b to the 4th power is in the denominator. And there's my answer to that one. For the next one, letter B, I have 3g to the negative 3 times h to the 2nd divided by negative 36, g to the 3rd, h, j to the negative 4. Okay, let's start with our fraction. 3 over negative 36 reduces. So you always reduce your coefficients. So that would be negative 1 over 12, negative 1 over 12. And I'm not going to put a 1 in the numerator until I know if I need it. If there's nothing up there, I will put a 1. But if there is something, I don't need that 1. It's not proper. Okay, where is my g's exponent the biggest? The denominator. So g is going to stay in the denominator. Whoops. G is going to stay in the denominator. I'm going to have it to the 3 minus negative 3. Where is my h's exponent the biggest? In the numerator. So I'm going to have 2 minus 1. And the j to the negative 4 moves to the numerator and becomes positive 4. So I have h to the first power, j to the fourth, divided by 12, g to the sixth power. That's the answer to that question. And for my last example, I am going to give you a challenge, and we will check this one. I promise I will remember. So example 10, I want you to try to reduce or simplify 42, r to the negative 2, t to the negative 6, u to the third power, divided by 14, r to the second, u to the negative third power. Thank you so much. I hope you have a wonderful day.